Hello, everyone. Fantastic to be here, and even better to see, but not so well, such an awesome crowd. Thank you for coming. My name is Patrycja, and today we are going to explore live Kubernetes hacking together. So get ready for a ride. But before the fun begins, let me introduce myself. I've been doing professional software development for over 25 years, so that's a quarter of a century. Quite impressive, isn't it? What can I say? I love it. However, 2 years ago, I joined the dark side of platform engineering at Form Free. At the moment, I'm staff SRE engineer. What do we do at Form Free? Basically, in 2 words, Form Free is a financial cloud. We provide a payment as a platform model for quick and easy integration with various payment schemes via REST API. We are fully remote, cloud-based with microservices architectures. And last year, we've built this new multi-cloud payment platform based on free clouds and Kubernetes. So obviously, Kubernetes security is super important to us. What am I going to talk about today? Just a splash of theory about Kubernetes architecture and Kubernetes risks. The key part of today's talk features 3 demos when I'm trying to exploit various misconfigurations in Workload just to get access to your accounts. But before the fun begins, let me introduce some overview of Kubernetes architecture, just for all of us to be on the same page, and to understand which parts of Kubernetes we could target while hacking. So basically, there is 2 main concepts in Kubernetes. We have control plane nodes and worker nodes. So the control plane basically manages the entire cluster. We have various components here. However, the key part is the API server. Basically, if we want to create or update any resource, we need to interact with the API server. Another very important component is etcd. etcd is a key value store, and basically it stores all information on all resources in a cluster. So think about secrets or any other sensitive data. If you want to get your hands on them, basically you need to access etcd. So that's one way to attack Kubernetes clusters. So when it comes to worker nodes, that's the place where the actual work happens. So the actual pods are running over there. The main component here is kubelet, responsible for instantiation and execution of pods. And if you attended my hacking session last year at GeeCON, you could see how I exploited unsecured kubelet API just to get access to the cluster. But that's not our demo today. Today, let's take a look at CNI. Container network interface on Kubernetes level. So basically, Kubernetes exposes this flat network security model where each pod can communicate with any other pod. To implement this model, they make use of this container network interface. That's only an interface, a specification. We have like several different implementations of this CNI. Think about Calico, Flannel, or Cilium. What's important here that usually those implementations, they create kind of an overlay network. So basically they create network over the a virtual network over an actual network. So how does it work? It works usually that way, that those implementations, they create a set of virtual network interfaces on each node. And then they use different mechanisms to forward traffic to right pods. Mechanisms like modification of IP tables or, for example, eBPF injected rules. This is important because once you, as a hacker, you are on a node, you can see all those virtual interfaces and you can, for example, sniff traffic. So that's like a high-level overview and some hints how we are going to exploit and execute successful attacks against our Kubernetes cluster. What are the risks when it comes to Kubernetes? We have different lists or models for Kubernetes risks. I guess that all of you are aware what OWASP is. That's this Open Web Application Security Project. That's a non-for-profit organization that aims at increasing awareness about security among developers. And they started like years ago with publishing this web top 10 risks. Since that time, they started publishing those lists, security risk lists, for various technologies. And only 2 years ago, in 2022, they published the security risk for Kubernetes for the very first time. And if you take a look at this list, basically number one is what we are interested in today, insecure workload configuration. But if you are interested and into hacking, you know that usually a successful exploit does not involve a single vulnerability. This is like only one step forward or one of many steps in a successful exploit. So with insecure workload configuration, there is, for example, often this number 4, lack of centralized policy and formats related. So because on one hand, you have this misconfigured, insecure deployments in your cluster. On the other hand, you shouldn't have them. They should be rejected, right? Because it's not only about taking care of what we configure, but also denying others a way to create malicious or insecure workloads. So another thing related also in a chain, usually of successful exploit, is like overly permissive RBAC configurations. Sometimes we assign too wide permissions to our users, then they can create, for example, some workloads while they shouldn't. And this workload, they can do whatever they want, like it may be insecure. So one more step into a compromise of your system application or even entire cluster. So another related issue is key 8 secrets management failures, because once you have, for example, like insecure workload configuration and, for example, you escape to node, you can read all the secrets from etcd. If they are not properly stored in an encrypted way, then you are done. That's like next step to compromise, for example, of your user's account. Because when it comes to Kubernetes secrets, you need to remember that those are not encrypted. They are only encoded. That's base 64 encoding only. So if you don't implement any extra protective mechanism, then your secrets basically are plain text. Another take on threat matrix for Kubernetes is this Mitre attack framework, and the detailed one prepared by Microsoft in 2021, and then next year, I think it was 2022, it was updated. Basically, Mitre attack is industry standard for modeling threats, like different threats. And Microsoft prepared this matrix dedicated to Kubernetes based on this Mitre attack framework. You see like different phases for a successful exploit, like initial access, execution, persistent, privilege escalation, and so on and so on. And this one takes a more detailed and more technical approach on specifying risks and possible threats. However, I would say it's not like exhaustive. So there is like a couple of things missing here, which I would myself improve. Anyway, that's a good start if you are interested in Kubernetes security and learning more details. That's definitely a very good source of information. So let's the fun begin, right? But I will need your help here. I have this demo application prepared. You can find the link on this QR code. That's basically GeeCON.yonlabs.com. You can find the link on my ex-Twitter account, YonLabs. So my kind request to you, please register a new account and log in and wait to be hacked. My objective here is to hack your accounts and learn your secrets. This is going to be like a 101 course in hacking. So we have only limited time, and I want to show you how a series of simple misconfigurations can lead to a total compromise of a cluster. So the link is available, as you see, on my Twitter account. That's a demo application. Obviously, don't use any real data, use nicknames. Don't reuse any real passwords because those could leak during our demos. So I'm logging in. I do see 2 users logged in. Perhaps I will wait for more. Please register, but we do have 2 users, 2 new users registered. So thank you for this one. And let me start with hacking. So I will do all the hacking from my evil server. This evil server is in the same subnet as my target Kubernetes cluster. And moreover, as a way of initial access, I have access to this John Doe credentials. those are only limited credentials, as you can see. Oops, sorry, I need to switch to John. Okay, I'm John Doe user. I do have quite limited permissions. As you see, I can't execute get nodes. What can I execute here? Let me check. So basically, I'm checking what can I do in this full app namespace. Okay, so what can I do here? Basically, I can do everything related to deployments and pods together with execution into a pod. So that's good, that's good. Let us create this pod. And basically this pod, what is misconfigured or perhaps not recommended configuration is like I mount this underlying host volume into my pod. So let's apply this one. Obviously, I'm creating this one in this full app namespace because I have access only to this namespace. I have access to those credentials for sort of full app admin. So let me create, let me exec into a pod. So that's gonna be this one, and that's gonna be this full app namespace. Oops. And I'm forgetting, yeah, I need this one as well. Okay, I'm inside a pod, as you can see, and I know that I have this underlying host volume mounted. So let me see. We do have access to this volume, and usually it's in case of like hacker getting access to a new system, it's kind of a reconnaissance, searching for some data, checking what's available and what's not. Here, basically, and also the easiest path to a successful attack is to find some like extra credentials which are left on a volume device, machine, or whatever. So let's look and search for some kube configs. We do have something here. So let me see what's here. And yes, we do have access to credentials, and that's Kubernetes admin. That's very handy. Like, I'm lucky, am I? So now, as this is the image prepared by me, I do have access to kubectl. So the only, sorry, it seems that live hacking is not that easy. That was home, Ubuntu, kube, and config. So basically, I want to use those credentials. Okay, so basically, now I am a Kubernetes admin, so I can do whatever I want, but I'm targeting this demo application. So let me see what pods are running in this cluster. Surprise, surprise, we do have some demo pod running here. So let's take a closer look at this one. Like, let me describe this pod in namespace backend and see what's here. We do have some secret here. So let's switch to our application and let's take a look how our application authentication mechanism is configured. I'm looking at session storage now, and I do see this, seems like a token, right? Seems like a JWT token. Yeah, so let's see this token. As you know, those tokens, again, they are not encrypted, they are encoded. So we can see like the plain header and payload, and we could see signature as well. So basically here we see that, yes, this is like JWT token, and it uses this HS256 algorithm to generate a signature. So what does it mean, HS256? It means HMAC with SHA-256. So basically this is a symmetric algorithm. If we have access to the secret used to generate this token, we could generate new tokens. So that's one way of approaching exploitation of JWT-based applications. So we want to find the secret used for generation of those tokens. Another way is like to find and get our hands on one of the tokens from the applications. One, we have like some token for another user, we could use it freely. So those are like two paths to a compromise for this application. Now, if we take a look at this one, we do see that this demo application has JWT secret key environment variable configured, and is configured based on this JWT secret from secret demo secret. So basically, let's see the secrets. We are the admin, so we could do whatever we want inside Kubernetes. Yes, we do have this demo secret available. So, okay, so basically, let's get this demo secret in this namespace, and let's output as YAML. Okay, so we do have, and we found the secret key. Let's try to use it. This page is really handy, and as probably you know, those JWT tokens, they use a set of claims to identify a user, and usually this subject claim, this one, is used to uniquely identify a given authenticated user. So here this is looks like sort of identifier. So let's try number 4. And what can we do now? Basically, we can just replace my token with this one and refresh the page. So, Caro, you've been hacked. Thank you for your help. Are you here? Yes, you are. And that's almost the first row. Thank you for such an effective cooperation. So what was wrong here? So basically, you see what I was talking about when it comes to OWASP top 10. First of all, number 1, insecure workload configuration. We had this host path configured, and it led to underlying host volume. So this was what the workload we created as hackers. However, you can think about any other actual workload running in the cluster with this kind of configuration and host path configured. You see how dangerous it could be. So another problem was for lack of centralized policy enforcement. So basically, we were able, even though we were like only admin one namespace, it was enough for us to create a new insecure workload in this namespace, and then step after the step to compromise another application running in the same cluster. Because of those credentials left on nodes. So basically, it's good to have some sort of admission hooks which basically deny and reject any misconfigured workloads. And that would be pretty helpful. Okay, so let's move to our second demo. In this demo, we will escape to node. Okay, I'm leaving this. At the moment, I'm in this evil server, and I still have access to this John Doe user. This user can create new deployments, new pods. So let's go full Monty and let's create this everything allowed pod. So basically we have like all misconfigurations possible. We are running this pod as a root user. We have this host network set to true, host PID to true, host IPC to true. We are running in privileged mode. We mounted this host volume. So yeah, and if possible, we are trying to schedule this pod on our control plane. So yeah, let's create this one. Okay. So I'm creating this one, and let's exec into this pod, and that's namespace full app. And yeah, and I need again bash. Okay. Nope. Yeah. I need this one. Okay. Even though I exec into a pod, if you take a look here, it seems I'm on this control plane, because with those full permissions plus privilege mode, basically it's almost if I were on this host. So anyway, what can I do here just to make it like fully compliant with direct access to the underlying machine? I need only change root to this underlying host volume, and now it's like I'm on the actual machine control plane. Here. So let's look. I was telling you about etcd. Let's take a look if we see etcd process. Yes, we do see this etcd process. So we are truly on the control plane of this cluster, and this one is very valuable. Why? Because basically this is the place where etcd stores the data. So let's try to access this etcd data with strings, which is basically like a user-readable approach. So this is like the sleep etcd, And what more we have? Yeah. And so you see that basically we have access, full access to etcd. So all information on all resources. This is more, perhaps not like super user-friendly format, but well, we are not complaining. We do still have access to it. We do need some knowledge on this format, but yeah, we had time, we researched, and let's find this register secret. So basically, again, we have access to this demo secret. Let's try to find it. Like grabbing with some context. And hooray, hooray! Again, we found this JWT secret key. Let me try if this is the same and whether or not it's gonna work the same way as the previous one. And let's try Lucky 7 now. And perhaps we will be able to hack another user. Okay, let me refresh, you know the drill. And hack me, please. Yeah, you've been hacked. Are you here? I don't see any hand raised, but anyway, I don't have a very good look with those bright lights. But you've been hacked. So what happened here? Yeah, obviously that was like full access to the cluster. We escaped to the node, but actually when it comes to reading this etcd, we didn't need this full access. It was enough to have the same configurations as in demo number 1, right? Only this host path mounted, and this way we would still have access to etcd database. However, you see that with this, those misconfigurations, basically you have access to the entire machine. So think like you could install extra software, you could dig deeper and find another secret, another data, etc., etc. You could like take the cluster down. You could install some malicious software here. So the sky is the limit here. Again, the problems with Kate 4, and again, the problems with Kate A secrets management failure. Demo secret is not encrypted, it's only encoded by default. So you need some extra mechanism, protective mechanism to protect your secrets at rest. And the last demo is about escaping to node. And this is gonna be like a little bit different. Let me get back to my evil server. Let me switch to user Jane. I will clear. Okay, so what about this user Jane this time? Again, Jane has pretty limited permissions. Let me find what actually they are. So again, I'm doing this listing, and I know the namespace just to save me some time. So that's like bar app namespace. And this time, with Jane, we don't have pods or pod exec permissions. We can only modify, create everything around deployments. So what about this case? Let me show you something what I've prepared. Basically here, we are using like the old trick of hackers and reverse shell. So what is a reverse shell? Basically, if you think about like regular path of accessing any remote machine, you are executing SSHing into this remote machine from your client machine. You are providing some credentials, there is some permission check, and you are given a shell. And reverse shell is the other way around. So instead of a client machine connecting to a remote machine, there is a remote machine connecting to a client machine, this way bypassing this credential check or permission check steps. So we are creating, this time we are creating this deployment with host PID set to true and security context privileged. And basically what we are doing, we are connecting back to our evil server and exposing bash. So to connect back to my evil server, I do need some process listening on the server. So let me access my evil server from a different session. Okay, so basically I need some process to listen on this 444 port. I'm gonna connect to from inside our pod created with this host PID true and in privileged mode. So the only thing I just need to actually apply this manifest and connection received. We are in. That was very handy. And now I should be able to like execute commands. You see that this time I'm on the actual pod, so that's the pod. So I would like to escape to node. What can I do here? Basically, let me see all the processes running here. We do have this number one process as been in it. Basically, this is the process from the host. So this is init for the host. If you know a little bit about Linux security model, you are aware and you are familiar with namespaces. So basically, I wanna enter the namespaces for different all the namespaces possible of this process, and then it would mean I'm basically on this host. And it's pretty handy that I'm running this one in privileged mode. I have access to those processes, and the only thing, and I am root. The only thing I need to access ns-enter stands for namespace, enter for target process number one, PID 1. I want to access all namespaces, and basically I want to run bash. Let me check this one, and now you see that instead of this pod, I'm on the actual host here. So I escaped to node. That was pretty easy, wasn't it? Yeah, so what can I do here? So this time I'm not on a control plane. I'm on a work node. So I don't have access to etcd. But I know about the CNI network model for Kubernetes, so I wanna see like all network interfaces. You see like a set of network interfaces here. Those are those virtual network interfaces for CNI. The actual CNI is Flannel. Okay, so we have access to them. So let me try and run TCP dump to sniff the traffic, and I will cheat a little bit here because I do know the port I'm interested in. But it's only a matter of patience in case of any actual hacker, right? So they could scan like different ports, see what's open, and basically sniff traffic on all of them. But that would require like very detailed analysis afterwards. So we are not that patient, and we don't have so much time, so I'm targeting this 1990 port. And now a kind ask to you, please refresh the pages in your in our web demo application. Yes, and we do see some traffic coming in, so again, thank you for cooperation. So, yeah. Let me search for something I'm interested in. Those headers and particularly authorization bearer token. So basically, this is one of your tokens. So let's see who's been hacked this time. Jonas, you've been hacked. Oh, thank you. Thank you. Thank you for your help. And that's all because of you, all those successful demos. So we've escaped to Node, and we've managed to sniff traffic and grab one of your JWT tokens. So again, regular problems here. K1 in secure workload configuration, this time with root, privilege, and host PID. Parameters misconfigured or configured insecurely. Then, again, lack of centralized policy enforcement. And one more. Unencrypted traffic and back connection to the Avil server was possible. So basically, I don't remember how many times I had this discussion with like more junior DevOps developers. We don't need encryption inside our private networks. This is like private, nothing wrong can happen, so we are safe. You see that this is like a series of small misconfigurations, and together they could lead to a successful compromise, a successful attack and compromise of the entire cluster. Here I've targeted only our web demo application, but actually, in reality, I managed to escape to Node. So the sky is the limit, and I could do whatever I want with, with this node, and a lot of bad things with our Kubernetes cluster. So you can read more about bad pods in this excellent blog post by Seth Art. So basically, some of those demos were based on his work and what he summarized here. He managed to describe like several cases of misconfiguration where everything allowed and different sets of parameters. And basically, obviously, with everything allowed, basically that's like a straight path to a full cluster compromise. With privileged and host PID, you've seen this path to a full cluster compromise as well, with escaping to node. With privileged only, there is like multiple paths to full cluster compromise, but they are more complicated, and some things depends on like underlying configuration as well. With host path only, our first demo, there is still like a path to as a full cluster compromise as a worst case scenario, depending on what's available and what you can find in this mounted volume. But basically, the things you are looking for as a hacker is like access tokens, kubeconfigs, what we did. You can add your SSH key. So think about adding SSH key to the underlying node. So you can SSH directly to this node, and then it means like a full compromise of this host. We could get access to hashed passwords, and we could try to crack them. So yeah, different ways to approach this one. With host PID only. So we have access to all the processes running on the underlying host. Obviously, we could kill those processes, so it would mean like denial of service attack. But also we could look for credentials, credentials that leak via execution command. Sometimes you provide some credentials in command line. So if there is a process still running, you see the entire command line of this process, and if it was provided in plain text, then a hacker can access it. Even though it's a process running on the underlying host, you don't have direct access to the host. You needed only this access, misconfigured pod with host PID only. With host network, there is like a potential path to a cluster compromise, but we could do a similar thing as we've done with this escape to node when we sniffed traffic. With host network, it means that pod has access to the underlying host network, direct access. So basically this pod could sniff traffic on all network interfaces available on this pod. So also with host network, we could bypass some network policies configured in our cluster. So that's another way of successful attack and another attack vector. With host IPC, we could perhaps address inter-process communication, but usually we don't use this one that much in our cluster. Still, could happen depending on what we are doing on our host. And even if nothing allowed, don't be so happy, because there is like so many other ways to compromise your clusters that you never know and don't feel too safe. Last year you could see like some other hacking demo from me which showed different misconfigurations. So basically that's like the tip of an iceberg. I could go on and on this one. And that's why I have a series of presentation of different aspects what could go wrong in Kubernetes clusters. It's important to remember those security paradigms. And one of them is the Swiss cheese security model, basically defense in depth. So we shouldn't rely on a single security mechanism. We need to have layers of defenses against potential threats, because nobody's perfect, no layer can provide like 100% security, and with having multiple layers, each layer covers the holes of other layers. So remember about this one. Remember that a fool with a tool is only a fool. So we need to improve ourselves. We need to know our tools, and we need to use them wisely. Basically, we have different paradigms, and I think that fundamental paradigm when it comes to software development is continuous learning. We need to keep learning to use our tools wisely. And that's what conferences are for, and GeeCON is one of the best. At least in my opinion. I hope you agree. So thank you for cooperation and such an effective help during my demos.